This is section 11.1, day 2. Here we're going to find the next four terms of each sequence. So here they've added 2, and then added 4 to get 7, added 6 to get 13. So we're going to add 8, then we're going to add 10, 12, and then 14. So 8 plus 13 is 21, and then 21 plus 10, we get 31. 31 plus 12 is 43, and then we add 14, which is 57. So there's the next four terms. Here they've added add 3, 6, add 10 plus 9 gets 19. So we're going to add 12, then 15, then 18, and then we'll add 21. So 19 plus 12 is 31. 31 plus another 15 is 46, and then another 18 is 64, and then add 21 is 85. Here on number 10, we're just going to find the first four terms, and we're going to plug in 1. That'd be negative 1 to the 1 plus 1 plus 1. So when you square negative 1, you get 1, and then when we add 1 plus 1, we get 2. So the second term is negative 1 to the third, because we're going to plug 2 in for that n. Then plus 1, so we get negative 1 plus 1 is, no, we're adding n. Yeah, I messed that up. Let's back up. We're not adding 1, we're adding 2. N is 2. So we get negative 1 plus 2, we get 1. A sub 3 is equal to negative 1 to the 3 plus 1 is 4. Plus 3 is equal to 1 plus 3. And we get 4. So the fourth term, we get negative 1 to the fifth, and then plus 4. That's negative 1 plus 4, and we end up with 3. Find the specified term of each sequence. So here we want the fourth term. So we have the first term, that's just given to us. Then a sub 2, the second term, is negative 3, a sub 2 minus 1, because we're plugging 2 in for n, and then plus 10. So that's negative 3, a sub 1 plus 10. A sub 1 is 5. So negative 3 times 5 plus 10 is negative 15 plus 10. That's negative 5. And then the third term is negative 3 times a sub 3 minus 1 plus 10. Well, that's the second term, so that's negative 5. So we have negative 3 times negative 5 plus 10, 15 plus 10, and that is 25. Now here's the fourth term. Here's the one that we're after. We have negative 3, a sub, it's 4 minus 1, so a sub 3 plus 10. So we have negative 3 times. A sub 3 is 25. Plus 10 is negative 75 plus 10. We get negative 65. Determine whether each sequence is convergent or divergent. And for 24, 26, and 27, we're going to look at the graphs and talk about limits with that. But for now, 18, we want to decide, let's write out a few terms and see what's going on. So a sub 1 is 4. A sub 2 is the one before. A sub 1 times 1.5, that's actually 6. A sub 3 is 9. And a sub 4, let's write a couple more. A sub 4, let's go to this. Let's go, we'll turn the calculator on here. And the one before is 9, so 1.5 times 9 is 13.5. So we get 13.5. How about one more? Let's take that times 1.5, and we get 20.25. And we start to decide, are we getting the sense that this is actually going to level off to something? Is it going to be convergent, or do we feel that it's just headed off to infinity and is divergent? Well, if you just keep multiplying by 1.5, the number is just going to keep increasing and increasing and increasing. So this is headed off to infinity, which means it's divergent. Let's look at number 24, but we're going to look at it in a little different way. Let's graph this. And if we go to mode and we go to sequential or sequence, let's go to y equals. And now we're going to plug in n squared plus 4. So n squared plus 4. Notice that when we hit our variable key, it has changed to n's instead of x's. We're going to divide by 3 plus n. 3 plus n. And let's go to the window. We can plug in 1 to n can be 1 to, let's say, 20 for now. We're going to start at 1, and we're going to, our step is 1, so it's going to do 1, 2, 3, 4, 5. Let's have our x minimum as 0, and our x max is, well, let's just go with 20. Scale we can do is 1. Y minimum, I don't think any of these are going to be negative. So for our Y minimum, we could probably just do -1. And then maybe we do, I don't know, we'll do 30 for the Y max. So when we graph this, we notice that, first of all, they're all dots. Because if you look at the mode, well, since it's only plugging in values like 1, 2, 3, 4, 5, it's not plugging in any of the real numbers. Like, I mean, the real numbers between the integers, like 1.5 or 1.7 or 1.88 or 3.6. And if you want to, we probably don't need to do this, but we could tell the calculator to just do dots. So let's look at the graph. And this is headed towards infinity. So first of all, this is certainly divergent. I don't get any sense that this will ever really level off. But let's look at the limit as n approaches infinity of n squared plus 4 over 3 plus n. Now, for extremely large values of n, plus 4, plus 3, it doesn't matter, like a billion plus 4 or a billion squared plus 4, the 4 becomes extremely insignificant. Not only that, well, after that, I should say, n squared over n, one of the n's is going to cancel. So we have limit as n approaches infinity of just n, because one n cancels, right? Well, if we plug infinity in this says it's just headed off to infinity, and again, we can write that this is just, it's divergent. Well, if we did the same thing for this one, let's actually do that. Well, let's graph all three of these. So we get y equals, and let's just clear this, and we'll go 5n plus 6 and divide by n. And I'll have to change the window, and I actually know that this levels off to 5, so maybe we, I don't know, go to 10, and we can see that it's actually leveling off to a value of 5. Well, let's take the limit as n approaches infinity of 5n plus 6 over n. Well, the 6 becomes extremely insignificant when the n values are very big. So this is the same as the limit as n approaches infinity, because we're approaching infinity, of 5n over n. Those cancel out, and we see that it's leveling off to 5. On number 27, let's graph this. We're going to clear this. And we have -1 to the n, and that piece causes this to alternate signs, negative, positive, negative, positive. But we're going to divide that, or times 1 over n. We could just divide by n. We'll have to adjust our window here, and 0 to 20 is fine. How about we go from -1 to 1? And we graph that, and we notice that it goes -1, positive 1/2, -1/3, positive 1/4, -1/5, positive 1/6. Well, the signs are going negative, positive, but notice that the distance, the dots are getting from 0 is getting smaller and smaller and smaller. So on this, we kind of forget the fact that it's going negative, positive. That doesn't actually matter as much as the limit as n approaches infinity of 1 over n. That's going to 0, because as the denominator gets really big, the fraction gets really small. So this is headed off to 0. It's leveling off to 0, but it's actually going negative, positive. So this is actually convergent. Convergent. Very good. Find the indicated sum for each sequence. And we have S sub 8. So we have the 8th partial sum. 8th partial sum. So we have A sub 1 is 1. And then A sub 2. So then we're going to add On the second one, we're going to take the first one and add, well, let me back up. I kind of messed that up. I didn't finish it out. No, I did. Actually, I'm good. A sub 1 is 1. So a sub 2 is, we take the previous one, which is 1, plus, and then we have 18 minus 2. And that is equal to, let's see, what do we get? 1 plus 16, 17. So a sub 3 is 17 plus 18 minus 3. 17 plus 15 is 32, right? So a sub 4, 32 plus, because we're going the one before. This is recursive. That's the one before. 32 plus 18 minus 4. That's 32 and 14. 46? Got a few more to go here. A sub 5 is 46 plus 18 minus 5. 46 plus 13. What is that going to be? 59. A sub 6 is 59 plus 12, because we have 18 minus 6. So that's 5, 6, 71. A sub 7. 71 plus 11. 11 is 82. And a sub 8 is 82 plus 10. 92. Let's add that up. Let's get out of this. And we're going to go 1 plus 17 plus 32 plus 46. 59. 71. 82. And under the O, 92. And we get 400. So S sub 8, the eighth partial sum, the sum of the first 8 terms, is 400. Find each sum. We're going to do exactly the same thing, but this is an explicit formula, so there's no recursion here at all. So when we plug in 1, we get 6 minus 11. When we plug in 2, we get 12 minus 11. Plug in 3, 18 minus 11. 24 minus 11. When we plug in 4, 5 is 30 minus 11. 6 is 36 minus 11. 7 is 42 minus 11. And finally, this tells us where to stop. We're going to plug 8 into this, which is 48. 48 minus 11. So negative 5 plus 1 plus 7 plus 13 plus 19 plus 25 plus, this is 31, and finally plus 37. Let's get this answer. Negative 5 plus 1 plus 7 plus 13 plus 19 plus 25 plus 31 plus 37. And we get an answer of 128. 128.